Hello student, good morning. I am Dr. Ajay Kumar Sinha, Professor of Chemistry. Today I am going to discuss osmosis and osmotic pressure. Last class I have discussed this depression in freezing point, elevation in boiling point, and numericals. This I have discussed. And osmosis and osmotic pressure, last class also I have discussed. Here related to osmosis and osmotic pressure, I will discuss a little more. Okay, because that question is asked in examination. Actually, there are three terms related to osmotic pressure. That three term I want to discuss. What is that three terms? Then first term is a isotonic solution. And second term is hypertonic, and third is hypotonic, hyper and hypo, hypertonic, hypotonic. Then these are important for examination point, particularly for medical. This question is asked many times. This actually other examination also, even for you in UPSC also, this type of question is asked. Then now I am going to discuss that these three terms. Okay, the osmotic pressure method, actually what is its application or use, importance, I will tell. Only in that I will discuss these three terms. The osmotic pressure method has the advantage. What is the advantage? This osmotic pressure method has the advantage over other methods, as pressure measurement is around the room temperature and the molarity of the solution is used instead of molality. You have seen molality was used in other properties, but here in the place of molarity is used. Okay, then pressure measurement, other things, pressure measurement is around the room temperature. Okay, this is very, very important. Pressure measurement is around the room temperature, and the molarity, capital M, the molarity of the solution is used instead of molality, LITY, means a mole per 1000 kg. Generally it is used, but here in osmotic pressure molarity, RITY, is used. As compared to other colligative properties, its magnitude is large. Again, second advantage. As compared to other colligative properties, its magnitude is large, even for very dilute solution. Magnitude is large. The technique of osmotic pressure for determination of molar mass of solute is particularly useful for biomolecules. This is again third advantage, useful for biomolecules. This technique is used for biomolecules, as they are generally not stable at higher temperature. biomolecules are not stable at higher temperature. Okay. Then this technique, because it is done at room temperature, then this is used in biomolecules determination. Okay. Now these things I told you 3 advantage, and polymers also, particularly protein and polymers, they are can say their solubility is poor. Solubility, polymers have poor solubility. Okay. And not stable at higher temperature. At high temperature they are not stable. That's why osmotic pressure is useful. I have a special advantage. Okay, I discussed these 3 points. Now I am coming to the 3 important terms. Then what is actually isotonic solutions? That you understand, very very important. Numericals is also asked based on isotonic solution. Two solutions having same osmotic pressure at a given temperature is called isotonic solutions. Very easy. Two solutions having same osmotic pressure at a given temperatures are called isotonic solution. When such solutions are separated by a semi-permeable membrane, no osmosis occurs. No osmosis occurs between them because osmotic pressure is same. Hence, no movement of solvent, no osmosis. For example, the osmotic pressure associated with the fluid inside the blood cell, fluid will be there. And meaning of fluid, you know, fluid means it is a liquid as well as gas. Okay, in a combined way it is called fluid. Fluid is not always liquid, it may be gas also. Then in cell these fluids are available. Then example I am telling you for this isotonic solution, that the osmotic pressure associated with the fluid inside the blood cell is equivalent to that of 0.9% mass by volume of sodium chloride solution. In sodium chloride 0.9% mass by volume, 0.9% sodium chloride solution is, its vapor pressure is equal to the fluid inside the blood cell. Both are equivalent. Okay, both are equivalent. Okay, means almost equal. That is the osmotic pressure of fluids inside the blood cell and this sodium chloride solution 0.9%. 0.9%. Okay, mass by volume. Both have same you can say osmotic pressure or equivalent, you can tell. Then this actually this actually is example of isotonic solution. Okay, fluid inside the blood cell and 0.9% sodium chloride solution. These two solutions have same osmotic pressure, hence both solutions are called isotonic solution. Normal saline solution, actually in hospital if you will go, first they will put you on this thing, saline solution. Saline, that is a salt solution, brine solution, you can tell. Okay, that in distilled water this will be there, means 0.9%. What you are telling? 0.9%. Sodium chloride solution is called dilute solution of sodium chloride is called saline water. Then normal saline water has this things NaCl solution. Normal saline solution, and it is for this normal saline solution. This solution is called that is useful when they will give to the patient. Generally, this saline solution is given to the patient, and this what is actually important for this I am talking you that if 0.9% you understood, that is its vapor pressure is equal to fluid inside the blood cell, and if we place the cells in solution containing more than 0.9% NaCl solution, mass by volume, more than 0.9%, and this fluid of the blood cell, if both are in contact, then what will happen? Think. Now you are understanding all the things. If both are in contact, but NaCl is in has this things concentration is more than 0.9%, then what will happen? More than 0.9% means that solvent will be less. Vapor pressure of this solution will become less. Correct? More the salt, less the vapor pressure of the solution. Correct? Because salt will increase, then vapor pressure will decrease. Vapor pressure will decrease. Then now, if both this fluid of the blood cell and this more than 0.9% NaCl, if both will be in touch with each other, then what will happen? That because it's a NaCl solution has a less vapor pressure, and blood will have a more vapor pressure. Then obviously that from the blood cell, can say solvent will come to the solution side. Then shrinkage will be there in blood cell. Shrinkage will be there in the blood cell, because movement of solvent will be from a blood cell, from the blood cell to the solution side. Okay. Then this I have told you that what will happen, that if we place the cells in a solution containing more than 0.9% sodium chloride, water will flow out of the cells and they would shrink. That blood cell will shrink. Such a solution is called hypertonic. Hypertonic. Correct? Because movement will be from the solvent from the blood cell to solution, sodium chloride solution, towards sodium chloride solution. Then this is called hypertonic. And in reverse case, if the salt concentration is less than 0.9%, okay, mass by volume, then what will happen? 0.9, less than 0.9%. Then what will happen? Now its vapor pressure will be more than blood cell. Okay, then now from the solution side, water will enter to the blood cell. Okay, the solution and this type of solution is said to be hypertonic. Hypertonic that side, now it is called hypotonic, hyper and hypo. Then when it is less than 0.9%, then NaCl solution will have more vapor pressure. Then now solvent from the NaCl solution will go to the blood cell. Okay. In this case, you can say water will flow into the cells, blood cells, if placed in this solution, and you can say swelling will be there. That cells will swell because blood has entered. Okay, this is these three terms: isotonic, hypertonic, hypotonic. These three questions are asked. Okay, now I am going to this little more. I will discuss the phenomena. You can say what we actually this few examples in the beginning I have given in the beginning. Then now you can understand pickle example I have given. Okay, raw mango. If a raw mango placed in concentrated salt solution, then loses water via osmosis. Means from the mango, raw mango, whatever water was there, that vapor pressure is more and salt solution vapor is less, and that's why water solvent from mango, it will come to the salty solution that side, and mango, what will happen? Then mango will shrived into pickle. It will convert into pickle. Okay, and flower revive when placed in fresh water. Then now again you can understand fresh water means high vapor pressure, and inside the flowers less vapor pressure. Then fresh water will enter to the flower and it will revive. Okay, a carrot also, a carrot that has become, you can say, this limp because of water loss into the atmosphere can be, if it can be placed, if it is a turned, this carrot turned, you can say dried or limp because of water loss into the atmosphere, can be placed into the water, making it firm once again, because fresh water will enter to the carrot, okay, by osmosis process. Water will, you can say, water will more, in this cases, carrot cases, already understood that water will move to the carrot. Okay, then in all this process osmosis is applied. Means movement of water from solvent to, always from solvent to solution, always, or from dilute solution to concentrated solution. Means dilute means more vapor pressure. Solution means if pure solvent and solution is there, then solution has less vapor pressure, solvent is more vapor pressure. Then this I have discussed. Okay, then all things happen due to the osmosis. Now I will discuss one more things I want to tell you, because question is asked. Term that swelling will take place, this in carrot, or even in body when water they will put in this. They will go to the hospital, and then when they will put this saline water, if they will put to the patient, then now patient will look good. Swelling will be there, little swelling will be there, and that swelling actually is called Adams, Edems, Adams. Question is asked. Swelling is called Adams. Okay. This can say in these things food in sometimes people say taking a lot of these things particularly sometimes people will take a lot of salt. They will eat more salt or salty food. Then that people will experience water you can say retention in their cells. Water retention in their cells and you can say intercellular space because of osmosis. And this term actually is called edemis, E-D-E-M, not edemis, edema. Okay, E-D-E-M-A, edema. That swelling is called edema. Okay, water movement from soil. Again, example I am telling you. Other example, water movement from soil into plant roots and subsequently into the upper portion of the plant is partly due to osmosis. From the soil root will take water, that is through osmosis, and from root it will go to the top, that is also partly due to osmosis. Okay, other reason is also there. Then that is also osmosis is working. Surface tension, that is surface tension, capillary action you might have studied, that is also one reason. This I told you. Now the permeable, I can say one more thing, very this thing, important things. Question is asked particularly in medical that prevention of meat by salting and of fruits by adding sugar. If actually it is protected, meat is protected, they will put some salts on the meat just to I can say preserve. And fruits, if you want to preserve, then sugar is added. Okay, some sugar they will add on the fruits to protect against bacteria action. You will think how bacteria they will protect from bacteria, meat or these fruits. Meat by putting salt, and fruits by putting sugar. What will happen in this case? Now you can understand that on meat they will salt they will put, then what will happen? Bacteria can't grow there, because as soon as they will come in contact with the salt which is put on the meat, then bacteria, whatever you can say water it has in his body, that because their osmotic pressure is more. In bacteria, whatever liquid is present, that is most of the liquids are water. Then its vapor pressure is more and salt vapor pressure will be less. In meat also some fruits will be there, liquid will be there. No? That side concentration that will be vapor pressure will be less. But in bacteria body vapor pressure will be more. Hence as soon as they will come, they will die, because all I can say this liquids will come to the meat side, salt solution side, hence it will die. Bacteria will not grow, bacteria will die. Same situation is with fruits. If they will come to the fruits bacteria, then how again here sugar is there, and now sugar solution. sugar solution, that is sugar, that they will put, then there again their pressure will be the vapor pressure of fruits. Vapor pressure of fruits. Okay. What will happen? That pressure will be less. Vapor pressure will be less and bacteria pressure will be fluids pressure in that solvent will be there. That pressure will be more. Then again that water will come to this side, fruit side. Then they will die. That's why for preservation time also osmosis works. Okay. Then I have given the important by this osmosis process, that against the this is used, osmosis is used against bacterial action. Through the process of osmosis, a bacterium on salted meat or candied fruit loses water, shrives and dies. Okay, bacteria dies. Then this I have told about the distinct advantage of osmotic pressure. I have given many examples. Now I want to solve one numericals, okay, based on osmotic pressure. And this question or this type of question is generally asked in medical examination, even for IIT also, particularly in main, because this is the Iitjee question. Okay. In general way also, other competitive examination, it is asked. Quickly you will understand this. It looks big, question is big, but if you read the question, then you will understand that it can be solved very easily. What is the question? I am reading now. 200 cc of an aqueous solution, 200 cc cubic centimeter, 200 cc of an aqueous solution of a protein contains 1.25 gram of the protein. 200 cc of the aqueous solution of protein contains 1.26 gram of the protein. The osmotic pressure of such solution is at 300 Kelvin is found to be 2.57 into 10 to the power minus 3 bar. Calculate the molar mass of the protein. Protein, actually about the protein you should know, protein's molecular mass vary too much. It can go up to the 50,000 also. 50,000. From less to, I am telling, this very too much variation is there. Different type of proteins are there. And their molecular mass, different molecular mass are there. Variation is too much. It will go up to 50,000 molecular mass. Then you can understand this value of protein. In our body, protein is playing a big role. Then calculation for protein is important. That's why in examination this type of question will be asked. But calculation is very easy. See here, all things are given. Formula you remember. Molecular formula, how will you calculate? That is the this formula is very easy. Here you apply that formula only. Volume is given 200 cc. That you can convert into liter. 200 cc, just divide by 1000. You will get volume in liter. That is the 0.200 liter. Temperature is 300 Kelvin. correct? R value is 0.083 liter bar per mole per Kelvin. Okay, this value is you should remember. Okay, value is not given. This value is not given. You have to remember R value, universal gas constant value. You should remember that is a 0.083 liter bar per mole per Kelvin. Then here see total 4 units are attached here. Liter bar per mole per Kelvin. Per mole per Kelvin. 2 extra things are there. Liter bar per mole per Kelvin. So already I have discussed in the beginning of the class. Then now how this value comes, that also I discussed. Then now R value you are knowing, T is given 300 Kelvin, volume in liter you are knowing. Then now you put that vapor pressure. This you have to calculate the molar mass of the solution. Molar mass of the solution. Then here this osmotic pressure is equal to CRT. Osmotic pressure is equal to CRT, that you know. C is concentration, and concentration is equal to mole per liter, and mole is equal to you can say mass by molecular weight. Mass by molar mass or molecular weight. Then finally already you know, after putting all the things, you are getting these things. Molecular weight is equal to W2 into RT divided by pi osmotic pressure into volume, pi B, osmotic pressure into volume. Okay, this M2 means molecular mass. Molecular mass is equal to means M2 is equal to W2 into RT divided by pi into V. Pi is here osmotic pressure. Then in this formula you can put all values. Then here that actually in question it is given protein mass they have given 1.26 gram. Protein mass is 1.26 gram. Then W2 value you have put. After that R value is given. R value is 0.083 liter var per Kelvin per mole. Temperature is 300 Kelvin. Divided by, here you will get this thing. You have to put the pressure value, pi. Osmotic pressure value is 2.57 into 10 to the power minus 3. Correct? And volume is 0.200 liter. Then all value now you have put. If you will solve, then you will find that after solving you will get 61.022 gram per mole. Okay, you will get after solving 61.022 gram. This is the molecular mass of protein. Molecular mass of protein. See? Then this is very easy. Only you have to just solve it correctly. Volume may convert into the liter, and R value you remember. Okay, R value always you remember, because many times they will not give this value. You have to use this value and remember this value. Okay. Now I am going to discuss reverse osmosis and water purification. You know, in every house this system is there, RO system. Then how does it function? RO, reverse osmosis. Then why the name itself, it is clear. It is based on osmosis. Osmosis, but here name is reverse osmosis. Then it is very easy to understand. Generally, solvent molecules goes to the solution side, means salty water side, via semi-permeable membrane. And you know, pure solvent like water has more vapor pressure than solution. In solution, solvent is there, but it is mixed with salt. Mixed with salt, it becomes solution. Then there this will be less. Solvent will be less, that's why pressure will be less. But pure solvent side, vapor pressure is more. That's why from the pure solvent side, water molecules, solvent molecules comes to the solution side due to the change in vapor pressure, that is called osmotic pressure. Change in pressure, that is osmotic pressure, vapor pressure of osmotic pressure, vapor pressure of solvent minus vapor pressure of solution, that is called osmotic pressure. Then now you think here new things, reverse osmosis. Now you want to purify the water. Suppose you have brought the water from, you can say ocean water or sea water, or tap water. Tap water sometimes will be salty. Okay. Then now you want to purify it. Then what we will do now? Because nowadays everywhere a scarcity of water, drinking water, but ocean and sea water is too much. Then how will you purify? What is that technique? Then that technique is very easy. Now you are knowing that what you will do artificially. Solution side, you will apply more vapor pressure than solvent side. Now, if you apply more vapor pressure on solution more than solvent, then what will happen? Situation will reverse. Whatever solvent molecules is present in solution side, whatever solvent is there, that solvent now from the solution side, solvent molecules, that will now move to the solvent side. Hence, in the beginning, to start the process, pure water is required. And solution side, if you have taken more water and you applied more pressure, more than pure water vapor pressure, then now situation will reverse. From solution side, it will go to the pure solvent side via semi-permeable membrane. Then this process is called reverse osmosis. Okay. Then now you can get all you can say solvent molecules which were present in the solution, all will come to this side. Only solution side, salt will be left. That can be removed. Then now you can see easily you got the this water, pure water you got from the salty water from ocean or sea. Then in this RO system, reverse osmosis filter, same things happens. Through one pipe, that tap water will go. Suppose that water is salty, correct? Then it will go to the, you can say that you can treat as a solution, and their filter they are using. Then that you can say through that filter now that will allow only these things, water solvent they can move, not the salt. Okay. Then this actually this semi-permeable membrane, they will have a special type of they will use film made up of cellulose acetate. Film of cellulose acetate will be there on semi-permeable membrane. In that a small hole will be there, orifice. Okay. Then through that water molecules, only it will allow water molecules to go. Then now always it allows only solvent molecules. Then now this time, reverse osmosis time, solvent molecules from solution side, it will go to the solvent side. Then there from through one pipe, through tap of water, that water will come, that you can treat as a this things solution. And inside of the filter chamber will be there, and different chamber will be there. The one chamber is for this water solution, tap water. Filter will be there. Then now after filtering, it will go to the other chamber, pure water. From that water you can use, you can drink. Then two pipe you have seen. One pipe just to supply that type of water to the filter tank, solution side. And this after filtering, it will go to the another tank. In that pure water will be there. It will go like that. Automatically some minerals will be there. That depends upon the quality of semi-permeable. Okay. Then now third pipe, we will find that for the waste water, one pipe will be there that will come out. What is that waste water? Actually, that waste water is that after filtering from the solution side, type of water, now solvent molecules came to the solvent chamber. Solvent molecules from the solution side. It will come to the another chamber, pure solvent chamber, that side. Then now in the solution chamber, salt will be remaining. Then this type of arrangement will be there, that when salt concentration, because solvent is coming, filtering, then now quantity of solvent will be less. Suppose 10 liter was you have taken in tank, 10 liter capacity was there, 7 liter filtered. Now 7-8 liter suppose is filtered. Then now salt which was present in 10 liter, now salt is present in 2 liter, 8 liter suppose filtered. Then that water, salty water, now it will come out as a waste water through third pipe. Then now I think you have understood what is the reverse osmosis and this how does it function. Both you have understood. Okay, impurities will be separated. Cellulose acetate is permeable in water, but impurities impermeable to impurities. Cellulose acetate is permeable to water, only it will allow water molecules to pass, but impermeable to impurities and ions present in seawater. These days, many countries use desalination plants to meet their potable water requirement. Okay, potable water requirement. Then this I have discussed about the this things, reverse osmosis and water purification. Now I am going to discuss the last portion of this chapter, that is the abnormal water, abnormal molar masses. Abnormal molar masses. This is a very, very important for all examination, particularly for advanced IIT, advanced and medical, and sometimes in general examination also. Okay. Then here you should understand, I want to brief you before going to details, that what is this actually abnormal molar masses. Actually, sometimes these things salt will give after dissolving in water. Suppose you have taken pure water. In that, if you are adding sugar molecules, then suppose 10 mole sugar you have added. Just simple example I am telling you. Then in solution, it will be 10 particles you can consider. This 10 moles means here 10 particles. And you know that colligative properties depend only on the number. What type of salt is there, it does not matter. In solvent, how many particles are dissolved? That number is important, not the nature of the you can say solute. This you know, that colligative property depends on the nature, depends on the number, not on the nature. But here what I am going to discuss, that abnormal molecular mass, if you follow the same principle for some salts like sodium chloride, sodium sulfate, magnesium sulfate, and you can say other salt is also there, then you will find that now what should be, what expecting molecular mass was there, that you will not get. By experiment. You will not get. You will find a different value, either less or more, but not theoretical value. You know that NaCl, its molecular mass is 23 plus 35.5, 78.5. Okay, just to add it, 23 plus 35.5, 78.5, I think. Then 78.5 is its molecular mass. But if you will experimentally check it, then you will not get 78.5 NaCl, KCl, like that way. Particularly NaCl example I given you, you will not get. You will get different value. And like that way, other example I am telling you, that this things acetate, acetic, this acetic acid is there, acetic acid. Then that acetic acid, there that time, what were you expecting, that value will not get. You will not get. This time you will get, you can say, less. Means here in a nutshell I am telling in a brief, that because in case of NaCl, in the beginning you are getting 1 mole of sodium chloride, you are telling 1 mole of sodium chloride. But if you will dissolve it in the water, now it will come in the, 1 NaCl will give 2 ion. Then now number will be double. 2 into what we have added, that number. It will, 1 molecule will give 2 ion. Or you can, this 1 molecule you are adding, it is becoming double. Sodium ion and chloride ion. Then now total number is becoming double. Then when this number will be more, if ions now number is more, particles becoming double. Theoretically it was 1, now it became 2. Then what will happen? Then vapor will be less. Vapor pressure will be less. You are expecting that only 1 ion, sodium chloride, 1 molecule added, then it will be only 1 molecule, 1 particle. But it is becoming double. then what will happen? Vapor pressure will be less. Vapor pressure will be less because salts are become, ions are double, particles become double. Then vapor will be less, then vapor pressure will be, vapor is less, then vapor pressure will be less. And when vapor pressure is less, then it will require more temperature to boil. Then it will require double temperature to boil, because vapor pressure is very less. It become what we were expecting, that now ions are double, then vapor pressure will be less, and vapor pressure will be less, then it will require more temperature to boil. Then it is a, means boiling will be, boiling point will be more, it will be double, what we are expecting. And this molecular mass, what will happen? That elevation of boiling point will increase, that you are knowing. Elevation of boiling point will increase. Then in that formula, by use of that formula, delta TV formula, you know that M2 you have to calculate, molecular mass of solute. Then in the place of you can say delta T, M2 will come to the place of delta T. Then now here vapor pressure is becoming, now you can say this thing, vapor pressure is becoming half what we are expecting. Then by use of this formula, if you will calculate, then you will find that now molecular weight will be half what we are expecting. Okay, means here two different type of molecules is possible. One will dissociate. One molecule can give 2 or 3 ions. Sodium chloride, potassium chloride, they will become double. And sodium sulfate, Na2SO4, it will be triple. Magnesium chloride, MgCl2, it will be triple. Hence, it will affect for both. Vapor pressure, it will affect to the vapor pressure, and vapor pressure is related to the molecular mass. It will affect to the molecular mass. Same way, some molecules will, I can say, association may take place. Means two molecules may become one molecule. As for example, acetic acid. Two molecules of acetic acid, they will dimerize and it will form one molecule. Two molecules of acetic acid, it will dimerize and it will make bigger molecules, one bigger molecules. Then now number of ions will become half. It was 2, now it becoming 1. In the first case, 1 was there, it was becoming double. Then due to this, you can say it shows abnormal molecular mass. Correct? Then for this, actually, one scientist was there. His name is Van Hoff. V-A-N-T, Van Hoff, H-O-F-F. V-A-N and T, Van Hoff. Its name is Van Hoff, scientist name. He has given one formula. He has actually introduced a factor, I, a small I, known as Van Hoff factor. I will come to the Van Hoff factor. Okay, this is related to abnormal molecular mass. Now I will go somewhat details. Okay. Then now I have briefed you all the things that now we know that compound when dissolved in water dissociate into cation and anion. For example, if we dissolve one molecule of KCl, 1 molecule of KCl. Now here K means 39, Cl means 35.5, means it will come 74.5 KCl, not NaCl. KCl, NaCl will come 78.5. Okay. Then here potassium means 39, Cl means 35.5, add it. NaCl 23 plus 35.5, add it. Whatever value will come, that will be. Then here in KCl, it is 74.5. NaCl, what will happen? NaCl 23 plus 35.5. What value will come? 23 plus 35.5, 58 I think. 58.5, whatever be. Okay. Then here you have seen that ionic compounds, when dissociated in water, when dissolved in water, dissociates into cation and anions. Okay. Example I have given you, KCl. In water, it will give, you can say, 2 ions. We expect 1 mole each of potassium and chloride ion. Okay. This will give, 1 will become 2 ions. Now if actually it happens, means if you can say we dissociate 1 mole of KCl, 1 mole of KCl in water, we expect 1 mole each of potassium and chloride ions to be released in the solution. If this happens, there would be 2 moles of particles. 1 mole of particles became 2 moles of particles in the solution. If we ignore interionic attraction, there will be attraction but ignore it, then 1 mole of KCl in 1 kg of water would be expected to increase the boiling point by double, 2 into 0.52 Kelvin. Okay, for 1 molecule, that Kb value is 0.52 Kelvin, but here it will become double. Then it will be 2 into Kb value, then 0.52 means 1.04 Kelvin. Now, if we did not know about the degree of dissociation, suppose we don't know, but this that now it will become double. Okay. Then now due to this double, it will affect to the, you can say, molecular mass. Then now 2 mole particles is 74.5 gram. This thing that in the beginning we know molecular mass of KCl is 74.5, and the mass of 1 mole of KCl would be mass of, experimentally if you will check, because now 1 is becoming 2, the vapor pressure increased means boiling, vapor pressure decreased, particles increased meant vapor pressure will decrease, means boiling point will increase, and then molecular mass will be half of the original. It was 74.5, but experimentally it will show half. Okay, because it is 2 times, it is affecting the number of you can say particles. It is multiplied by 2, hence molecular mass will be half. Remember it. How many? It is dissociating into how many particles? That you divide by that number. Then 74.5 divided by 2. It will give 37.25. Then experimentally you will get 37.5. But in fact its molecular mass is 74.5. Okay, 37, I will get 37.25, because 74.5 divided by 2, it will come half. Then now reasoning you understood why it is happening. Then this brings into light the rule. This is the requirement actually. Rule that when there is a dissociation of solute into ions, the experimentally determined molar mass is always lower than the true value. Always it will be lower. Maybe sometimes, because always it will not be 100%, it will not dissociate, 90% will dissociate, 95% dissociate, then near about double you will get. Okay, near about double, not exact you may not get. Okay, then now this I told, when it dissociate into, I can say many, double or triple, then you can divide actual molecular mass. What is their theoretical? Divide by 3. Experimentally you will get like that only. It will be less than the actual. Okay, theoretical. Actual means theoretical. Okay. Then now another case I told you, association is also possible. Association is also possible, that two molecules may become one molecule. Example already I have given. 2CH3COOH, it will dimerize and it will form, you can say, CH3COOH whole, and outside 2 you can write CH3COOH. In bracket you write a small bracket, and outside the bracket you write 2. And this equilibrium sign you can show. 2CH3COOH, sign of equilibrium, CH3COOH in bracket whole 2, down 2. Because this happens, why it is happening? Because there will be, this happens due to the hydrogen bonding. Two molecules of acetic acid will dimerize, means due to the hydrogen bonding. O and H will come close. Correct now? OH will, one acetic acid, another acetic acid will come close. Then hydrogen bonding will be there. Okay. Due to that hydrogen bonding, association takes place. Molecules of ethanoic acid, acetic acid is also called ethanoic acid. Molecules of ethanoic acid, that is the acetic acid, dimerize in benzene. It will dissolve in benzene, only then it will happen due to hydrogen bonding. This normally happens in solvents of low dielectric constant, because high dielectric constant means the attraction will be there. But here it will happen in low dielectric constant. And in this case, the number of particles is reduced due to dimerization, means 2 become 1. Association of molecules is, actually you can understand by this thing. When they will come close, you can imagine when both two molecules are coming close, they will make hydrogen bonding. Okay, and 2 will become 1. It also be undoubtedly, we should not undoubtedly stated that if all the molecules of ethanoic acid associate in benzene, then delta TB in case of elevation in boiling point, or in case of freezing point, delta TF. Same formula is there, term is different. Delta TB or delta TF for ethanoic acid will be half of the normal value. Delta T value will be half. Why half? Because now 2 is becoming 1. 2 ions is becoming 1 particle. 2 particles are becoming 1 particle. Then now this thing, the vapor pressure will be, you were expecting that vapor, if 2 particles was there, then you are thinking that vapor pressure will be less. But now 2 is becoming 1. then now vapor pressure will be more. Vapor pressure 2 is becoming 1. Then now more solvent will go, means vapor pressure will be more. Vapor pressure will be more because now 2 became 1. Then trouble is, the disturbance is less, and some more solvent will go to the vapor phase. So then this will increase, vapor pressure will increase. Then vapor pressure will increase. Then boiling point will decrease. Boiling point quickly will get, boiling point will decrease. Then it will affected by term 2. Correct? Because vapor pressure will become half in this case. Because vapor pressure is more, then it will be close to somewhat atmospheric pressure. Hence you have to heat less than half. Then when it is the half, then reverse case will be of molecular mass. Molecular mass will be double. Boiling point and molecular mass is oppositely. You send delta T is equal to a formula that this M2 is in down. Correct? Then delta T and molecular mass are, you can say, inversely proportional. That's why it will become now half. Molecular mass become half. This is the important things I told you. This delta T, it will affect to the delta T or delta F. Therefore, it will be twice, means boiling point or freezing point will be twice the expected value. What we are expecting there, you can say twice will be there. Delta T means I am talking about the elevation in boiling point or depression in freezing point. That will be double. Okay, and for this type of molecules, molar mass that is either lower or higher than the expected. Or expected means normal, also you can tell normal value. And this, in a simple way tell, in this case it will become half. In the case of acetic acid, ethanoic acid, it will be half. But in general, you can tell in the abnormal cases, in general, that molar mass that is either lower or higher than the expected value. Expected value means normal value, is called abnormal molar mass. This less molar mass or less or more molar mass, this is called actually abnormal molar mass. This less or more molar mass, that is it is less or more from the expected value. Expected means normal value. Then formula has been given by Van 't Hoff. What is the formula? Then I means Van 't Hoff factor, that is equal to normal molar mass divided by abnormal molar mass. This you remember always. Normal molar mass divided by abnormal molar mass. And this is also related. You can tell in two ways. First I told you normal molar mass divided by abnormal molar mass. That is one way. Other way also you can tell observed colligative properties, in the term of colligative properties. Observed colligative properties means experimental, you can tell, experimental colligative properties divided by theoretical colligative properties, means calculated. Calculated means theoretical. Then observe means experimentally. Observe means experimental. Then observed colligative properties divided by calculated colligative properties. This is also called Van 't Hoff factor I, small I. Okay. Then now in terms of moles also you can tell that the total number of moles of particles after association or dissociation. This is the third relation I am telling about. All three are used while solving the numericals. Then I is equal to total number of moles of particles after association or dissociation divided by number of moles of particles before association or dissociation. Means upside what you are telling, that is also observed. Total number of moles of particles after association or dissociation, that is a simple way, that is observed. Total number of moles of particles after association or dissociation, it means observed, divided by number of moles of particles before association or dissociation. That is a theoretical. Then now I have told you about I. Okay. Then now these things little more is remaining. It will take time related to this abnormal molecular mass, and numericals are also there. Then I will discuss in the next class. Now I am stopping only here. Thank you.